Deep within our planet, a mystery lies hidden. Two colossal masses, unlike anything we've ever seen, lurk in Earth's mantle. These enigmatic structures, dubbed blobs by scientists, challenge our understanding of Earth's formation. They hint at a past far more dramatic than we ever imagined. These are not just geological anomalies, they are potential relics of a cosmic collision that shaped our world. For decades, these blobs have puzzled geologists. They are colossal, dwarfing even the largest mountains on Earth's surface. Their composition is strange, distinct from the surrounding mantle, and their very existence raises profound questions about the forces that shaped our planet billions of years ago. The quest to unravel their secrets has led us on a journey back in time, to the very birth of our planet. Join us as we delve into the heart of our planet, exploring the mysteries of these enigmatic blobs and their connection to a cataclysmic event that forever changed the course of Earth's history. Imagine structures so massive they could swallow continents whole. That's the scale of the blobs lurking beneath our feet. Located deep within Earth's mantle, these behemoths reside on opposite sides of the planet. One hides beneath Africa, the other under the Pacific Ocean. They are colossal, each one nearly twice the size of the moon. But their size is not their only remarkable feature. These blobs are dense, far denser than the surrounding mantle rock. They are like lead weights embedded in a sea of rock. This density difference has a profound effect on how seismic waves, generated by earthquakes, travel through the Earth. Scientists use these waves to map Earth's interior, much like doctors use ultrasound to see inside the human body. When seismic waves encounter the blobs, something strange happens. They slow down. This slowing effect tells us that the blobs are not just different in composition, but also in their physical properties. They are likely hotter and more viscous than the surrounding mantle, behaving more like honey than solid rock. These characteristics have led scientists to believe that these blobs are not native to Earth. They are remnants of a celestial visitor, a protoplanet named Theia, forever entombed within our planet's depths. Theia. The name evokes images of a distant, lost world. In Greek mythology, Theia was a titan, the mother of the moon goddess Selene. In astronomy, Theia represents a celestial phantom, a protoplanet whose existence is hinted at but not yet definitively proven. Scientists believe that Theia, roughly the size of Mars, once orbited the Sun in the early solar system, not far from the young Earth. But Theia's journey was fated to be a short one. Gravitational interactions with other planets in the chaotic early solar system nudged it onto a collision course with Earth. This was no glancing blow. It was a cataclysmic impact, a cosmic event of unimaginable violence. The energy released in the collision would have melted Earth's surface, vaporizing oceans and blasting debris into space. Theia, shattered by the impact, would have merged with the molten Earth, leaving behind only fragments of its former self. These fragments, scientists believe, are the very blobs that now reside in Earth's mantle. But how did they survive the inferno of the impact? And what evidence do we have that Theia even existed in the first place? The Theia hypothesis, as it is known, is not just about explaining the mysterious blobs inside Earth. It also provides an elegant explanation for one of the most enduring mysteries in our solar system, the origin of the moon. For centuries, scientists have pondered how our planet came to have such a large, relatively close companion. The moon is unusual in many ways. It is much larger relative to its host planet than any other moon in our solar system. It has a remarkably similar composition to Earth's mantle, but with some key differences. And its orbit is tilted at an angle that doesn't quite align with Earth's equator. These characteristics have puzzled scientists for generations. The Theia impact hypothesis offers a compelling solution. According to this theory, the debris blasted into space by the collision between Earth and Theia didn't just disappear. Instead, it coalesced over time, drawn together by gravity. This process of accretion, as it is known, gradually formed the moon. The moon, in essence, is a child of catastrophe, born from the ashes of a planetary collision. Section 5. Echoes of Theia evidence in the depths. The Theia hypothesis, while compelling, is not without its critics. Some scientists argue that the evidence for the impact is circumstantial. They point out that we have yet to find any direct evidence of Theia, such as fragments of its core or mantle on Earth's surface. However, proponents of the Theia hypothesis argue that the evidence, while indirect, is nonetheless strong. They point to the unique isotopic signature of lunar rocks, which differs subtly from that of Earth rocks. This difference, they argue, suggests that the Moon formed from material that originated elsewhere in the solar system, such as a Mars-sized protoplanet like Theia. Furthermore, the specific composition of the blobs, particularly their high iron content, aligns with what we would expect to find in the mantle of a protoplanet like Theia. The very existence of the blobs, their size, density, and location, all point towards a cataclysmic event in Earth's distant past, an event that could have only been caused by the impact of a massive object. And Theia, the phantom planet, fits the bill perfectly. Section 6. Simulated Reality, Recreating the Collision. To test the Theia hypothesis, scientists have turned to computer simulations. Using sophisticated computer models, they can recreate the conditions of the early solar system, including the orbits of planets and protoplanets. By adjusting the initial conditions of these simulations, they can rewind the clock, tracing the paths of Earth and Theia back billions of years. These simulations have yielded some remarkable results. By fine-tuning the parameters of the impact, scientists have been able to reproduce many of the observed features of the Earth-Moon system, including the Moon's size, orbit, and composition. These simulations have shown that a head-on collision between Earth and a Mars-sized object would have produced a debris disk with enough mass to form the Moon. Furthermore, the simulations have shown that Theia's core would have likely merged with Earth's core, explaining why we don't see evidence of it today. Meanwhile, fragments of Theia's mantle, denser than Earth's mantle, would have sunk towards the core, eventually forming the enigmatic blobs we observe today. Section 7. The Elusive Proof Challenges in Finding Theia. Despite the compelling evidence from computer simulations and the unique characteristics of the blobs, the Theia hypothesis remains just that, a hypothesis. The challenge lies in finding definitive proof. We have yet to find a smoking gun, a piece of evidence that conclusively proves Theia's existence. One avenue for finding such proof is through further study of lunar rocks. The Apollo missions brought back hundreds of pounds of lunar samples, but these samples have only been superficially studied. By analyzing these samples with more advanced techniques, scientists may find subtle differences in their isotopic composition that could provide definitive evidence of Theia's contribution to the Moon's formation. Another avenue is to study the blobs themselves directly. This, however, presents a significant technological challenge. The blobs are located deep within Earth's mantle, far beyond the reach of any drilling technology we currently possess. Accessing them would require developing entirely new technologies and drilling techniques, a feat that is unlikely to be achieved anytime soon. Section 8. Unveiling Earth's Secrets. Future Research Avenues. The quest to unravel the mysteries of the blobs and the Theia hypothesis is far from over. Scientists are actively pursuing multiple lines of research, each one holding the potential to shed new light on this ancient cosmic event. One promising avenue is the study of exoplanets, planets orbiting other stars. By observing the formation of planetary systems around other stars, scientists can gain a better understanding of the processes that shaped our own solar system. These observations may reveal whether giant impacts like the one that formed our Moon are common or rare events in the universe. Another avenue is the development of more sophisticated computer models. By incorporating more realistic physics and a wider range of variables, scientists can create even more accurate simulations of the Theia impact, further refining our understanding of the event and its consequences. Section 9. Our Cosmic Story, Rethinking Earth's History. The discovery of the blobs and the ongoing research into the Theia hypothesis have profound implications for our understanding of Earth's history. They suggest that our planet's evolution was not a gradual, linear process, but rather a chaotic and violent one, punctuated by cataclysmic events that reshaped our world. The Theia impact, if proven true, was a defining moment in Earth's history. It not only gave us the Moon, but may have also played a crucial role in shaping Earth's geology, its atmosphere, and even the conditions that made life possible. The blobs, these silent sentinels in Earth's depths, serve as a constant reminder of our planet's tumultuous past and the cosmic forces that shaped our world. They remind us that we are part of a much larger cosmic story, a story that began billions of years ago with the birth of stars and the formation of planets. a story that continues to unfold today, hidden within the very heart of our planet.